Okay, so for unit 6.3b, okay, for 6.3b, we are going to go over some radical equation, I'm going to call these exceptions. Okay, exceptions are like technicalities. Technicalities, not fatalities. Thanks for thinking that. Okay, so first thing is if you have, and we're going to go over a couple different situations here. Okay, if you have a radical and it has an even handle number. Okay, you have an even handle number. So generally a 2 or a 4. Okay, we don't usually go any farther than 2 or 4. And it has a positive value underneath. Okay, so an even handle number with a positive value underneath. Okay, so something like the square root of 16. Okay, what would your answer be? 4. So is it safe to say that if you have an even handle number and a positive value, your only answer will be what?
Even positive number.
Not always an even positive number, but a positive number. Okay, something like root 25 would give you 5, which is odd. But if you have an even handle number and a positive number underneath, okay, you can get positive answers only. Okay, your answers will only be positive. Okay? How about if you have a even handle number, and if it's not positive, then it would be negative. Even handle number and a negative number underneath. So something like root of negative 16. What do you think our answer would be? Even handle number with a negative number underneath. For instance, root negative 16. What's the square root of negative 16? And if, just in case we didn't realize this, remember there's always an invisible 2 here if it's not right. Can you multiply 2 identical things together to get a negative 16? No. Okay? This cannot be simplified. Okay? Cannot simplify. The easy way to say that is no solution. Okay? So 0 with a slash through it. It cannot be done. We cannot multiply 2 integers together, the exact same things, and get a negative. It just doesn't work. Okay? Another scenario would be if you have a positive number underneath your radical. Okay, so a positive number with an odd handle number. Okay, positive number with an odd handle number. Something like the cube root of 8. Cube root of 8. What happens if I ask you for the cube root of 8?
2.
It's a 2. So what conclusion do you think could be made about something with an odd handle number and a positive number underneath?
It's always positive number.
Always positive. Okay, so you would get a positive answer. Right? And you would only get a positive answer. Then the last type of situation that you might see is if you have a negative number underneath the radical, with an odd handle number. Okay, so an odd handle number with a negative number, underneath the radical. So something like the cube root of negative 8.
Has to be negative.
Can you do that? Can you take the cube root of negative 8?
Yes.
Yes, because 3 negatives can give you a negative answer. So here your answer would be negative 2. So point here is we can basically make the conclusion that a negative number underneath the radical with an odd handle number, you will get a negative answer. Okay, so we went over these a couple of days ago, but these are going to be fairly important in what we go over right now. So just wanted you to make sure that we're clear on that. The only other one that is a little bit special, I guess you could say, because it tends to really confuse people, is if you have a 0 underneath a radical. Okay, 0 underneath a radical, and positive or negative in your handle number. Okay, positive or, not positive or negative, any handle number. So it could be even or odd. Okay, let's just write any handle number.
It's 0.
What's the square root of 0?
0.
0. What's the cube root of 0?
0.
0. So any handle number, any root of 0 is going to be 0, no matter what. Okay, it could be positive, or excuse me, it could be odd or even. Does not matter. Okay, so the rule that I'd kind of like you to memorize here, okay, the most important thing you need to remember is if you have an even handle number, whatever is underneath the radical must be greater than or equal to 0 in order for something to work, in order for you to be able to simplify this. Okay, if you have an even handle number, you have to have what's underneath the radical be greater than or equal to 0. Okay, so most of you guys are pretty good at this when you have numbers, okay? But what if I throw in some letters here? Something like, for example, number 1. If I ask you to solve, okay, solve root x equals negative 4. If I asked you to solve that, root x equals negative 4. How would you solve that? Any ideas? What do you think we do?
Square both sides.
Okay, square both sides. Anyone else have a different thought? Leave it there? Okay. Sam? Yes. Okay. Is it possible to put a number underneath a radical, an even-handled radical, and get a negative answer? No. So you have to look at this. This is no solution. It cannot be simplified. Okay? You cannot do that problem. Even if you're going backwards. Okay? It is not possible to put any number underneath a radical and get a negative answer. It's just not possible. Okay? So this answer is no solution. Okay? If you write no solution or cannot simplify, it's the same thing for me. I don't really care which way you write it. It's going to be the same thing. Okay? Next thing I'd like you to do is we're going to look at just some true or false questions. Yeah. There you go. Good? Okay, so next ones I'm going to look at true or false. Now, on your homework, it is going to ask you to, if false, give a counter example. Okay, that basically means tell me why it's false. You do not have to do that part. Okay, all I care about is true or false. I just want you to say true or false. You don't have to give me a counter example. Okay, so true or false for number 2, that the cube root of x cubed is always a real number. The cube root of x cubed is always a real number. So essentially what that means is whatever you put under there, you're going to be able to get an answer. Okay, a real number. We haven't gone over things called imaginary numbers yet, but for now, can the cube root of something being cubed always be simplified? Can that always be simplified? Or is this ever going to be no solution? Can you think of any situations where this would not be able to be simplified?
Is 0 a real number?
0 is a real number, yes. Real numbers basically are whole numbers, decimals, fractions, positives, negatives, anything like that. So basically this is asking you, can you simplify that equation? Could you simplify it? Yes. Okay. the cube root of x cubed is always a real number, that is true. Okay? I'm going to give you a major hint here. When I let you write that note card for this test, put that on there. Okay? Write it on there. And make sure you see the words always a real number. You should write always a real number. Okay? You may have a test question that's not exactly this question, but it's a form of it. Okay? Next one, again, true or false. For number 3, I would like to know true or false. The square root of x plus 3. The square root of x plus 3 is always a real number. Square root of x plus 3 is always a real number. Okay, and while you're writing that down, I want to go back to this first one, back to number 2, okay? The reason this works is it does not matter what is underneath the radical. You will always get an answer from a cube root because it's an odd handle number. Okay, so odd handle numbers, you can put anything underneath the radical and you can do the problem. Even handle numbers, it's different though, right? What did we say about even handle numbers? If you look back, if it's an even handle number, whatever's underneath the radical must be greater than or equal to 0. So does this work for any number that you can think of? No. What if I gave you -4? -4 plus 1 would give you -1. Can you take the square root of -1? No. So is this always a real number? Will you always be able to do this problem? No. So in this true or false, this is false. Okay? It is not always a real number because it has limitations. Okay? You have to have it greater than or equal to 0. The next thing that we're going to go over is, I only have 2 of them. I want to know for what values of x, does each expression, represent a real number? For what values of x does each expression represent a real number? So basically now, instead of saying, will it always work, I'm just going to ask you to figure out when will it work, okay? When will it work? When does it not work? So something like number 4, for what values of x does this expression represent a real number? So basically I'm asking you, when does this equation work? When can you do this equation? Can you give me a number value to give me the limitations on when this equation works and when it doesn't? What did we decide? That the radical must be what? Whatever's underneath the radical must be what? We wrote it on the page before this. Greater than or equal to 0. It's okay to get the square root of 0, right? Is it okay to take the square root of a negative number? No. Can you take the square root of a positive number? Yes. So that's how we came up with must be greater than or equal to 0. The way that you do this is you take whatever's underneath the radical and make an equation. Whatever's underneath the radical, set it greater than or equal to 0 and solve. How would you solve this equation? No, we're not doing absolute values, so this has nothing to do with sandwiches and stuff. How do we get x by itself? Subtract 3. Okay? Subtract 3 from both sides, so this is telling me that x must be greater than or equal to -3. So for what value of x does this equation work? Anytime your x value that you're plugging in is greater than or equal to -3, then that is an okay problem to do. Okay? That's when you could do this problem. That's your answer. So x must be greater than or equal to -3. And then the last one we're going to do for number 5, the last one for this set of notes, is root x squared minus 25 equals x minus 5. And I'm going to give you some multiple choice, okay? This is equivalent for what values of x? For what values of x? And I'm going to give you some multiple choice answers here, okay? Only when x equals 0, for all values of x, for no values of x, so basically it never works, or your last choice is only when x equals 5. So when does this work? When is this question correct? I'm going to give you kind of a strategy to solve these types, okay? First thing you want to look at with these types of questions is look at the exceptions, okay? And I want you to plug them in. So we don't know if all values work. I don't know if no values work. But the way you can kind of eliminate those answers is start by plugging in the things that they say. So does it work when x is equal to 0? So plug that in, okay? If you plug this in, is it true? Is the square root of 0 squared minus 25 equal to 0 minus 5? 0 squared is 0, minus 25 is root negative 25. Is that equal to negative 5?
No.
Does that work?
No.
No, this does not work. So that tells you it definitely does not work when x is 0. So if it doesn't work when x is 0, will it work for every single value of x? No, we just proved that it doesn't work when x is 0, so there's no way that one works. Now, we've eliminated 2 answers there basically. Now I want you to try the other value that they give you, and you're always pretty much going to be given at least 2, maybe sometimes 3 values, okay? Now I want you to plug in when x is 5, okay? So I checked the first one, then I just want you to plug in when x is 5. So 5 squared minus 25, is that equal to 5 minus 5? 5 squared gives you root 25 minus 25. Is that equal to 5 minus 5? Is the square root of 0 equal to 0?
Yes.
Yes. So does it work when x is 5?
Yes.
Yes. Therefore, if it works when x is 5, you can't say that it never works, which is what C was. So it does work for a value. They gave it to you, okay? This would only work when x is equal to 5, okay? Trust me, this is another one that you should memorize, write down, make a note of, however you see fit, okay? Big hint, those 2, okay? So what you're actually doing for this part of homework is I have considerably cut down your homework today, okay? It used to be 1 through like 37 odd, okay? The only ones that you're doing for this are on worksheet 3B, which you do not have, so I will give to you. Worksheet 3B, you are doing numbers 16 through 28 only, okay? So you're doing all of 16 through 28. It's like 12 problems. Right? And they're all dealing with, they're either the true, false. I don't have to have a reason. I just want you to write true or false. And then some that are kind of like this. Okay? Anyone have questions on how I did any of that?